Hi dear students, welcome to my channel. Now I am continuing the previous class. What I started is fundamental quantities. No? Three fundamental quantities already I taught. The fourth one is luminous intensity. Unit is candela. Symbol is CD. This fundamental quantity mostly we use in optics. The other one is amount of substance. Unit is mole. Symbol is MOL. Another one is thermodynamic temperature. Unit is Kelvin. Its symbol is K. This amount of substance and thermodynamic temperature. These two fundamental quantities mostly we use in heat and thermodynamics. The last one is electric current. Its unit is ampere. Its symbol is A. It is capital A. This fundamental quantity we use in electricity and magnetism. I think you understand what are the fundamental quantities, their units and their symbols. I will tell some interesting thing about these fundamental quantities. In the universe, any event you will describe in terms of these seven fundamental quantities. These seven fundamental quantities, we call them as a dimension of the universe. So dimension of the universe is 7 because any quantity out of 7, any one fundamental quantity cannot be written as combination of remaining 6 fundamental quantities. That is why these 7 are 7 dimensions of the universe. Okay. Now fundamental quantities we have completed. Next we will go for derived quantities. The meaning of derived means you are deriving particular quantity by using some other quantities. Okay. So these 7 fundamental quantities we will use to derive some derived quantities. For example, you take speed. Speed is one of the physical quantity. Speed is equal to distance divided by time. Distance is length. Time is simple time only. So length divided by time. So this length and time are fundamental quantities used to derive speed. So speed is a derived quantity. Okay. Similarly, velocity also. Velocity equal to displacement by time. Displacement is again length by time. Velocity and speed both have same units. Only difference is speed is a scalar quantity, velocity is a vector quantity. Regarding vectors and scalars we can discuss in other chapters. Okay. We will go for other derived quantities. You take acceleration. Acceleration definition is rate of change of velocity. Simply we can write velocity divided by time. Okay. For velocity already we have told before, velocity is that is length by time divided by time again. So length by time square. Okay. Now you are understanding what is the meaning of a derived quantity. For the derived quantity, this speed, velocity, acceleration and momentum also, mass into velocity, momentum P is equal to. Another one is force you take. Force F is equal to ma, mass into acceleration. Okay. And work W is equal to F dot S. F is the force, S is the displacement. Okay. These are all derived quantities because these quantities are derived by using fundamental quantities only. Okay. For the same quantities, you can derive their units also. Okay. Now, for the speed, distance by time, no, there is length by time. Length you can measure in terms of meter, time second. So, meter per second is a unit for speed or velocity. Okay. Similarly, you take momentum. Momentum is equal to mass into velocity. Mass is kilogram, velocity is meter per second. The unit of momentum is kg meter per second. Okay, you take acceleration. Acceleration is rate of change of velocity. That is nothing but velocity by time. For the velocity unit already you have derived, no? That is meter per second divided by second. So meter per second square. The unit of acceleration is meter per second square. Another derived quantity, you take force, F equal to ma, no? M is the mass, unit of mass is kilogram. A is the acceleration, unit of acceleration is meter per second square. So the derived unit of force is kg meter per second square. Okay, but there is some unique unit for force, that is Newton. So 1 Newton is equal to 1 kg meter per second square. This unit is in the system of SI or MKS. For the force, one more unit is there in CGS system, that is dyne. Okay, so 1 gram centimeter per second square is a unit of dyne. Okay, so you can convert the units from one system to another system. Suppose 1 Newton is equal to 1 kg meter per second square, no? Now you convert kg into grams. 1 kg is equal to 1000 grams. 1 meter is equal to 100 centimeter. If you substitute this, 1 kg meter per second square equal to 10 to the power of 5 gram centimeter per second square. That is nothing but 1 Newton is equal to 10 to the power of 5 dyne. You try at your home, you write this values on your notebook and you will get this relation. The relation between Newton and dyne is 1 Newton is equal to 10 to the power of 5 dyne. Okay? Okay, we'll take one more derived quantity, work. Work is equal to F dot S. F is the force, S is the displacement. For the F, the unit is kg meter per second square into meter only, because for S is displacement, no? Unit of displacement is meter. So the unit of work is kg meter square per second square. Okay. General unit of work or energy in SI system or MKS system, joule. So 1 joule is equal to 1 kg meter square per second square. Okay. Similarly, you can convert this unit into CGS system. Before I told you. So in CGS system also there is one more unit for work or energy, that is erg, ERG, erg. The relation between joule and erg, 1 joule is equal to 10 to the power of 7 erg. You can try this. Okay, I think you're understanding how to convert the unit from one system to another systems. Like this, there are many derived quantities are there in the physics. I hope these lectures are enough to understand what are the fundamental quantities, what are the derived quantities, what are their units, how to convert from one system to another system. I think this is sufficient for this fundamental quantities and derived quantities. The next class or next video, I am going to present the dimension analysis. What is the importance of dimension analysis in the physics? And what are the limitations? That video I will soon prepare and I will put. Till then, bye bye.